Okay, let's take a look and see how you did on these. So let's start up here with the first one. Following our order of operations, we have to work inside the parentheses first, or enclosing symbols. What has to be done inside there first? Multiplication happens before subtraction. So 5 times 3 is 15. What's next? 4 minus 15, which is negative 11. Now normally I'm down to a single number inside the parentheses, so I could take the parentheses out. But since it's a negative 11, I'm going to leave it there for a second just to make sure that I keep that as a negative 11 and don't try to subtract 11 or something, so I don't get it confused. Next I have 5 times the negative 11 is negative 55. And 6 plus negative 55? Negative 49. Good. How many of you had negative 49? Anybody have any questions on that one? How to do it? Okay. Moving on to the next one. Obviously, we start in parentheses again first, enclosing symbols. 412 minus 4 is 408. Now there it's not negative, so once I've reduced that to a single number, I can remove the parentheses. What's next to do? The division. 408 divided by 4 is 102. And then 3 times 2 is 12. And then 3 times 2 is 6, isn't it? Never mind. That's what I can get for coming to work totally sober for once. So 102 minus 6 is 96. For those of you who don't know me, I was just kidding, by the way. Never totally sober. Third one, where do I start? 8 times 4 is 32. We're going to make you guys do all the hard work since at this time at night my calculator is broken. What's next? 13 plus 32 is 45. Minus 2 is 43. Now for this one, that fraction bar means we have to do everything on top first. So I'm going to write that down here quick. 8 plus 3 times 7 minus 1. Let's do that first. What part there do I have to do first? 3 times 7 is 21. And then 8 plus 21 is 29. Minus 1 is 28. So the top of that is 28. What do we do first on bottom? 6 times 4 is 24. And then 5 times 2 is 10. And then 24 minus 10 is 14. So this is 28 divided by 14, which is 2. Anybody have all 4 of those right? Good deal. Any questions on those? Okay. Well, before we get into any new material, is there anybody that was not able to get into my math lab? We're all in successfully? Okay.
I could have been in the wrong section, so that's why I emailed you.
Yep.
And I still don't know what I went through something that seemed like a quiz or a test first. And I came back to the other department, so that's when I emailed you.
Okay. So we get into my math lab. When you first get in there, it's going to look like this. Whatever comes up. There we go. This here is your list of all assignments that are open that you can work on. So this is saying there's a homework that's due tonight. That's actually due in about 20 minutes now. That's the one that was assigned last Tuesday. There's a quiz here that's going to be due tomorrow night at 11:59 p.m. Then another homework assignment that'll be due next week, Thursday.
Where do you find
It says
out?
due September 7th.
It says due September 8th, doesn't it?
Oh, okay.
Did I click on the wrong one? That's why.
So I click on your home.
Yeah, maybe I should go back and get that right. Hopefully it's not going to be one of those nights.
Why should it be different from the day?
Okay, so there it is. That's the homework from last Thursday. That's the quiz that's due tomorrow night. There's the homework that's due next week.
Click on the homework button over in the
If I click on the homework over here, that'll give me a list of all the homework assignments for the whole semester. So that's where you make sure you find the homework.
Yeah, I don't know where I went to begin with.
If you click on quizzes and tests, right now there's only the one quiz in there that's due tomorrow. Yesterday, actually 2 hours ago, that would not have been there.
Okay, then, I don't know where I was, but at least it wasn't.
If you scroll down, you get to these are practice tests. And those are samples. Those are just practice tests that come with the book. They're not part of the class. They're just extra practice that you can do. So stay on the homework. Now tonight there will be a quiz. The quiz is open right now. So sometime either tonight or tomorrow you have to go into the quizzes and tests and take quiz 1. That'll be due tomorrow night at 11:59 p.m. Okay. No, anything off of the homework that anybody wanted to go over? What's that? Always assume that you got to reduce fractions to lowest terms, no matter, even on my tests. That'll cost you if you don't reduce them. Yes.
I'm just gonna throw here that if you put numbers in front of me,
Yeah.
that'd be a problem. Vocabulary, I kind of get.
Okay.
Integers, all of
Yeah. And math does kind of have its own little language.
Yeah.
So as we go through, hopefully you'll get used to them. Otherwise, let me know and we'll go over them again for you. Like integers.
Just look them up on Google too, that might help. It'll give you the definition of them.
Yeah, I've done that too, but for some reason it's maybe the process or something, or I'm just
Okay.
freaking out probably.
Sure. And that's usually a lot of it at this point is nerves.
Yeah.
This class is not near as bad as it sounds, just so you know. The worst part about this class is the teacher.
It's the what?
The teacher. I hear he's really mean. Okay. So,
all over the school is the nice one.
okay. So tonight's topic, we're going to start out, we're going to get into the algebra side. Last week was the arithmetic. So we're going to start looking at algebraic numbers. Looks like that. And we mentioned a little bit last week that this is just like any other number. It has two parts. It has our count, in this case the 4, telling us how many of something we have. And it has our name, in this case the x, which tells us what it is we've counted. And those variables, those algebraic numbers, work just like our whole numbers, our fractions, or decimals. When we go to do operations with them, if I have 4x plus 13x, when I add or subtract, remember there's two things. When I add or subtract, one, I must have the same name. If we do not have the same name, we cannot add or subtract numbers. That was the same label if we're dealing with whole numbers, inches or feet or pounds. The same denominator if we're dealing with fractions, common denominators. Decimals in the same place value. Algebraic numbers, that comes down to having the exact same variable. The second thing with adding and subtracting is we keep the same name. So up to my example here, do they have the same name? Yes, x and x. They both have exactly the same name. So we combine our counts. 4 plus 13 makes 17. And then what do we put in for the name? Just x. We just keep the same name. We don't do anything to it. We just keep it. What do we get here? 7y plus 5z becomes, there we go, 7y plus 5z, because they don't have the same name. Now, just because there are different names out there does not always mean that there's nothing we can do. We can run into problems like this. Now we look at this and we look at the first two digits here, or terms. We got 5x plus 3y, and we look at, well, they have different names. We can't add or subtract. But if we look at the whole problem, we have 5x here and we have 9x there. We can at least combine the parts that do have the same name. So 5x and 9x make 14x. And then we have the 3y. It's a positive 3y, so it stays as plus 3y.
Does it matter how you write it? Like in favor of 3y plus 14x?
That really doesn't matter, no. But mathematical grammar, usually alphabetical order if they have the same power. Otherwise, if they have different powers on them, the highest power variable usually comes first. But it's not, wouldn't be wrong by any means if you did. Our negatives, of course, come back to haunt us. So here, 7a minus 9b minus 13a plus 11b. When we're dealing with algebraic numbers, the symbol in front of the number, it goes with the number that comes after it. So there's no symbol here, so that is a positive 7a. This here, minus 9b, has to be thought of as a negative 9b. This is a negative 13a and a positive 11b. So when we go to combine things here, we have 7a and a negative 13a, which makes what? Negative 6a. Positive 7, negative 13. Oh, we end up at negative 6. Now we have 9b and 11b, or negative 9b, I should say, and 11b. Negative 9 and positive 11. Where does that end up at? Positive 2b. Now I have these algebraic numbers here. I have to connect them with something. Since it's a positive 2b, I put a plus in there. So I end up with negative 6a plus 2b.
This is Greg.
Yeah, Greg.
Do you always take the larger sign of the larger number?
Okay, when you're combining two numbers, and that's exactly right. If you have different signs, the number with the larger absolute value or the longer vector is going to be the sign of the answer. Now, rather than trying to remember rules like that, that's why I do the vectors. You know, this was negative 9 plus 11. I start at 0. I go negative 9. Positive 11 goes the opposite direction, and it's longer, so it takes us to the positive side. So that tells me that the answer is positive. And since the arrows go the opposite direction, it's the difference between the two values. So the difference between 11 and 9 is 2. So that tells me that's a positive 2. But you're absolutely right. When you're adding a positive number and a negative number, the one that has the largest value or the largest absolute value is the sign of the answer. Okay, so this one here. What can we combine? Negative 7x, negative 9x. Make negative 16x. What's next? Okay, 5z and negative 14z make negative 9z. Good. Now the negative is already there to connect them, so that's just 16x minus 9z, or 16x and negative 9z, however you want to pronounce it. Any questions? Now we're not going to use it a whole lot in this course, but if we were going on to more of a formal algebra course, they would get into polynomials. And just to talk about those just briefly, because some of you will go on to a bachelor's, you're going to have to take a college algebra and statistics. I know I said the S word, I'm sorry. Somebody brought up statistics earlier and mentioned how much they loved them. So, looking at our place values, I'm just going to put in numbers here. We have ones, tens, hundreds, 1,000s, 10,000s, and so on. But what we have is a decimal number system, or sometimes called a base 10 number system. What base 10 is referring to is an exponent where the number, the base number of the exponent is a 10. Each of our place values is determined by an exponent that has a base of 10. Anything to the power of 0 is 1, so the ones place is 10 to the power of 0. 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is our 1/1000s. 10 to the power of 4 is our 10,000s. 10 to the 5 is the 100,000s, and so on. All of our place values are those powers of 10. So when we were looking at writing our numbers in their full form or expanded form, like 628, we wrote that out as 600s and 2 10s and 8 1s. But we could have just done this. 6 times 10 to the 7th, and 2 times 10 to the 1st, or just 10, and 8. We don't need to put the 10 to the 0 there because it's just ones. Now with our number written out like this in its full form, we can compare it to an algebraic number and see the similarities. If we look here, we see the place values are 10 squared, 10, and then there appears to be nothing there, but it's 10 to the 0. We look at our algebraic number. If you think of these digits as the values and the variable as the place value, we can see this is the x squared digit, this is the x digit, and this would be, appears to be nothing, but it would be the x to the 0. Algebraic numbers are nothing more than a number that is written in a base of a variable rather than 10. So when we go to work with these algebraic numbers, this, most of us think of it as being 3 separate terms or 3 separate numbers, is a single number with 3 digits. And we would work with it just like we would any 3-digit whole number. So let's say I have 5x squared plus 7x plus 3. And I want to add that to 3x squared plus 9x plus 4. Now the parentheses there are not telling us to do anything first. It's just like when we were working with negatives, they separate out the numbers so we know which numbers go together. I can write this out just like I would any whole number addition. Write the first number down, 5x squared plus 7x plus 3, and then I line up my place values. 3x squared goes under the 5x squared. 9x goes under the 7x. 4 goes under the 3. And I am adding down my columns. Now, just to stay consistent, just like with whole numbers, I'll start at the right and I'll work my way back to the left. 3 plus 4 is 7. So it's positive 7. 7x plus 9x, 16x. Now, here's one of our differences between our algebraic numbers and whole numbers. Algebraic numbers, there's no carrying. That we can have multiple digits there. We can have 16x there. We don't have to carry the 1. Then we go to the x squareds. 5x squared and 3x squared, 8x squared. Now we saw a negative in our opening questions there. Negatives do come pretty heavily into our algebraic numbers. So I'm going to point out another big difference between our algebraic numbers and our whole numbers and integers. With our integers, every digit is either positive or every digit is negative. For example, if I have negative 237, that is a negative 200s and a negative 3 10s and a negative 7 1s. In an algebraic number, it's possible to have negative 7x squared, a positive 3x, and negative 11. Each digit of an algebraic number can be positive or negative on its own. You can see here, this is a negative, this one's positive, and this one's negative again. So I have to account for that or keep track of that when I'm doing my operations. I might have 3x squared plus 7x minus 13 plus 5x squared minus 9x plus 2. So I go to line things up again. 3x squared plus 7x minus 13. 5x squared minus 9x plus 2. And I am adding down my columns. Negative 13 and positive 2 makes negative 11. So I have to be careful with my negatives. 7x and negative 9x make, careful, positive 7, negative 9 makes negative 2. So negative 2x. And 3x squared and 5x squared, 8x squared. Good. So I'll keep track of our negatives. Now I realize a lot of you are taught when you're adding, call them polynomials, you just take out the parentheses and combine like terms. That works. That's just a shortcut for what we're doing here. This is actually a long or full-blown way of adding polynomials. Looks just like adding whole numbers. If you want to subtract, this is where things get kind of ugly. So 7x squared plus 5x minus 9. And we're going to subtract 4x squared minus 9x plus 2. Once again, we make sure we line everything up with its place value. 4x squared under the 7x squared. Negative 9x under the 5x. And the 2 under the negative 9. And now we are subtracting down each column. So we have to be very careful. This is negative 9 minus 2. I'm going to write it off to the side. Negative 9 minus 2. I'm going to change that to a negative 9 plus a negative 2, which is negative 11. 5x minus a negative 9x. So I'm just going to combine the values here. 5 minus a negative 9 is going to become 5 plus what? Positive 9. 5 plus 9 is a positive 14. It's a positive 14x. 7x squared minus 4 is 3x squared. So be very careful. Those negatives can be really a pain when we're, especially with polynomials. Now again, some of you that have had high school algebra have been taught what I'm going to do is I'm going to distribute the negative is the term they used. I'm going to make this negative, this positive, and this negative. And I'm just going to get rid of the parentheses and combine them just like with addition. And that does work, but that's, again, it's just a shortcut for doing this longer process of subtracting the columns. Yeah, I'll actually do a different example of that rather than confusing the two of them together there. So let's say I have 3x squared minus 9x plus 5. And I'm going to subtract 8x squared plus 2x minus 9. Rather than setting it up in columns like we did, you can change, just like when we were doing subtracting, if we had 8 minus 4, we said you can change that to 8 plus a negative 4. It's the same thing applies here. I'm going to change this to plus a negative. Well, to make that a negative, everything in here has to change. So this becomes a negative 8x squared. This becomes a negative 2x. And that becomes a positive 9. So now I combine my 3x squared and my negative 8x squared is negative 5x squared. I'm combining my negative 9 and negative 2 to make a negative 11x. Positive 5 and positive 9 make a positive 14. I still have to deal with the negatives. I'm just no longer subtracting, I'm adding. So all that is done is change my subtraction into addition. What they did is they did it all at once. They changed all these signs at once instead of putting them off to the side like I do, and as you go down each column, changing it from a subtraction to plus the opposite. They're doing it all in one big swoop. Now, as I said, that's not a terribly important skill for this class, but it's something if you go on, it is something you will be expected to know in a college algebra course. So we've done addition and subtraction, and the big thing is, just like with any other form of number, when we add or subtract, we can only combine things that have the same name. So now let's look at multiplication and division. The big things with multiplication and division is we don't need the same name. And we're going to also combine the names. Whereas when we added or subtracted, we just kept that same name. So if I have 4x times 3x, these happen to have the same name, but it really doesn't matter. When we go to combine them, we're going to combine the counts like we always do. We're multiplying, so it's 4 times 3 makes 12. But since we're multiplying, we're going to also combine the names. X times x is x squared, so 12x squared. Well, then we multiply. We might have 7x times 5y. They have different names. Can I combine them? Yeah, when I'm multiplying, I don't need the same name. I'm going to combine the counts. 7 times 5 is 35. Then I'm going to also combine the names. X times y is just going to be xy. I could have something like this, where I have 3 numbers multiplied together. When I do that, I have to multiply them 2 at a time. 4x times 7y. I'm going to combine the counts, just like always. 4 times 7 is 28. X times y, xy. Now we still have to multiply by the 3x. Combining the counts. 28 times 3 is 84. Xy times x. Well, I can combine the variables with the powers that have the same base. X times x is x squared, and then we have the y. No, it doesn't. Multiplication is associative, so I could have multiplied these two first, or I could have done those two first. Yeah, I got 12x squared and then times 7y. That works just fine as well. Now we're going to look a little bit more at the powers next week. Some things that happen. What if we have powers on our variables? Like 5x to the third times 7x to the fifth. So we're going to multiply the counts. 5 times 7 is 35. And we're going to look at our rules for powers a little bit more next week. But x to the third times x to the fifth. Remember, x to the third is 3 x's multiplied together. X to the fifth is 5 of them multiplied together. If we multiply those, how many total do we have multiplied together? Careful. 8. There we go. X to the 8th. There are 8 x's being multiplied together. So it's just 3 plus 5, or 8 total x's being multiplied. So x to the 8th. We'll look at that a little bit more next week when we look at rules of powers.
It just makes no sense.
I know it's everybody's saying, why are we adding? Well, yeah, we're not really adding, but it's the appearance is that we're adding, because it is really multiplying. You know, x squared times x to the 4th. This is x squared is x times x. X to the 4th is x times x times x times x. And if we're multiplying those, it's, you know, I'm not going to say 6 x's, but we do have 1, 2, 3, 4, 5, 6 x's multiplied together. That's x to the 6th. It just turns out that the appearance is the powers are being added, but we really are multiplying the exponents themselves. Remember, the powers are just part of the exponent. Well, what we've looked at so far is multiplying a one-digit number by another one-digit number. Kind of like taking 7 times 3. We multiplied those out. What I want to look at next is, what if I have a two-digit number times a one-digit number? So what if I had something like a 32 times 4? Now remember, 32 I'm going to write out long form, 3 10s and 4 1s. Now I'll multiply that by my 4. Oops, where'd the 4? 3 10s and 2 1s, there we go. And I'm multiplying by my 4 1s. I'll do 4 times the 2 1s is 8. 1s times 1s is 1s. And then 4 times the 3 is going to be 12, so I'm going to have to carry. I keep 2 in the 10s, and I carry 1 over to the hundreds. Algebraic numbers work the same way. If I have 3 times 2x plus 5, this in the parentheses here is not two separate numbers. 2x plus 5, remember, is a single two-digit algebraic number. So I'm multiplying that 2x plus 5 times 3. So I do 2x plus 5 times 3. And just like I did right up here, 4, and then 4 times 2, and then the 4 times 3, I do the same thing here. 3 times 5 is 15s, positive 15s, but plus. 3 times 2x, 6x. So I multiplied out. That's the long multiplication, just like whole number multiplication. Now, most of us were taught a shortcut called distribution. And all that does is taking this exact process, and it's just shortening it, making it so you don't have to write it out. So you're going to take the 3 and you're going to multiply everything inside the parentheses by 3. So 3 times 2x is 6x. Then you do 3 times the positive 5 is positive 15. Notice exactly the same answer. It's a little bit shorter and a little less work. If you've had algebra before, chances are you were taught this and have never seen this before in your life. If you like doing it this way, it's just an extra way of helping. That is the actual process without all the shortcuts. From here on out, I'm most likely going to do it this way in class. Unless somebody has a question, I can show them the long way. But we can have something like this now. 7x times 3x minus 8. So now remember, we could do 3x minus 8 multiplied by 7x. 7x times negative 8 is a negative 56x. And 7x times 3x is 21x squared. I know I went a little faster. I'm going to slow it down and do the distributing over here. I'll get the same answer, but we're going to do the shortcut now. So 7x is in front of the parentheses. Technically, first we should ask if there's anything we can do in the parentheses. The answer here is no. There's nothing we can do there. So then the second question, is there anything that has to be done to the parentheses? And yes, it's being multiplied by the 7x. So we multiply every piece inside the parentheses by the 7x. 7x times 3x. 7 times 3 is 21. X times x is x squared. Now we have to be careful with this next piece. This is 7x times a negative 8. 7 times negative 8 is negative 56. X times nothing is just x. Bless you. Look at something like this now. We have two parentheses there. Is there anything we can do inside either set of parentheses? No. There's nothing we can combine because they don't have the same names. Those are each just two-digit numbers. There's nothing to do there. So the first one, is there anything that needs to be done to that set of parentheses? Yeah, multiplied by the 5x. So 5x times 3x, 15x squared, perfect. 5x times positive 2, positive 10x. Now we have this one, this other one, we have to multiply by the 2. 2 times 5x is 10x. 2 times negative 7, negative 14. Are we done? No, we still have pieces that have the same name that we can combine. The 15x squared has nothing to combine with. But we do have 10x and 10x, which makes 20x. Then the negative 14. Try this one in your notes, see what you come up with. So looking at this one, is there anything to do inside either set of parentheses? No. First set of parentheses is multiplied by 3x, so let's do that. 3x times 5x is 15x squared. 3x times negative 4, negative 12x. Now here's the part most people mess up. The second set of parentheses is not multiplied by 2. Multiplied by negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative 7, positive 14. So now there's nothing to combine with the 15x squared. But we do have negative 12x and negative 6x, make it negative 18x. And they're positive 14. Again, we're not going to get into this a whole lot for this class, but I do want to show you a two-digit number multiplied by another two-digit number. If we refer back to our whole numbers again, like 32 times 41. Remember, this 1 has to multiply the 2, but it also multiplies the 3, and so on. The 4 has to multiply both digits as well. Our algebraic numbers work exactly the same way. I'm going to move down here to get more room. 3x plus 5 times 2x minus 7. Negative 7 times 5 is negative 35. Negative 7 times 3x is negative 21x. Now we move over. Negative 2x times 5. Or sorry, positive 2x times 5 is positive 10x. Notice I line it up just like with whole numbers. We left a 0 or left a space there. Same thing. I leave a space. I can line up my x's with my other x's. 2x times 3x, 6x squared. And I can combine my place values. Negative 35, nothing to combine with that. Negative 21x and a positive 10x is a negative 11x. And 6x squared. So it's the exact same process as dealing with whole numbers. Those of you that had an algebra class at some point have probably been taught FOIL. The F of FOIL stood for first. You multiply the first two digits in each number. 3x times 2x is 6x squared. Notice that was down here. O stood for outer or outside. 3x times negative 7, negative 21x. I stood for inner or inside. 5 times 2x is a positive 10x. And L stood for last. Multiply the last digits of each number. 5 times negative 7 is a negative 35. Notice those are all the numbers we had here. And of course we still have to combine. Negative 21 and positive 10 make a negative 11x. FOIL is not something we're going to need to do a lot for this class as well, but again, that's that next step in our operations with algebraic numbers if you were to go on. Last thing I want to show you is division, and we're just going to simple single digits. 18x squared divided by 3x. Just like with multiplication, when we divide, we do not need the same name. And when we divide, we're going to also combine the names. So 18 divided by 3 is 6. X squared divided by x is x. I'm not going to show you a whole lot more of that, but the one biggest thing I want to point out about these operations. Multiplication happens to every digit. When I had 3x plus 2, if I multiplied that by 5, I had to multiply the 3x, and I also had to multiply the 2. So multiplication and division happen to every digit of a number, every item there. Addition or subtraction only happen to the digits that have the same name. If I have 7x plus 8, and I want to add 3 to that, where do I add the 3? To the 8. I can only add that to the digit that has the same name. In our next hour, we're going to look at solving equations, and that's very important. When we add or subtract, we can only combine it to things that have the same name. When we multiply or divide, we will combine it with every digit. Okay, it's about that time for our first break, so we're going to go ahead and take our break. We will come back at 6:19. Let's come back at 6:29.